Have you heard the name Arduino board? Have anyone heard this name Arduino?
Yes,
Yes,
sir.
sir.
Arduino, you have heard that name
Yes.
Arduino board?
Yes, sir. Names
Yes,
now.
sir.
Yes, sir.
Okay, have you performed any experiment using that board?
Yes, sir.
Okay, so for those people who know that Arduino boards, this tool is this software is very useful. So let's we begin with that software. So is screen is visible to all?
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
So
Yes,
the
sir.
first step is you search that tool, Tinkercad, Tinkercad, sir. It's a Tinkercad tool. You search this tool, you will find the first link Tinkercad, create 3D design, digital design with online CAD. You go to the login page. So you will get this interface. Are you able to get this? Tinkercad Lab. You search for the Tinkercad Lab. Go to the login page. You can create your account or you can log in through your Google account. So you create your account or you can log in through your Gmail account. So you log in with the Gmail account. Once you logged in into this Tinkercad, Autodesk Tinkercad, you'll get this interface. All of you are able to see this window, this interface.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes.
So you are at this stage. So at the right hand side, you click, you can see your profile, your name. So this I have created my own account. So this is with the name Vaibhav Nima, and the new design notifications and all these parts are there. Now at the left hand side, there are the four means sections are there. The 3D design, circuits, code blocks, and lessons. 3D design is only used to design a 3D circuits, the digital circuits, that is generally used for the PCB printing or PCB designing. And code blocker is used to design a codes for Arduino boards and all this. And lessons are actually few practicals are there. Now you have to click on the circuits. Once you click on the circuits, so you'll get this create a new circuit. All of you please click on this circuits, and then you press this key, create a new circuit. So the new window will pop up and you will see this interface of this window. All of you, are you able to get this window, pop-up window, new pop-up window?
Yes, sir.
Okay.
Yes, sir.
Yes,
Yeah.
sir.
So see what this window is having. This is used for rotation of components. We can rotate components. Suppose I have to flip our content or rotate our components. So we can rotate our components. This is a delete button, so we can delete a particular components, undo, redo, and some nodes are there. Node tools are there. You can do that. And this is useful for the wire type. You can choose a different type of wires, or normal wires, hookup wires, alligators, or automatics. But abhi, now for a very early stage of practicals, we only require the normal wire, and you can change the color of that normal wire. We generally use for the ground signals, we generally use the black color, and for the positive, we generally use the green color. So we'll do that also. So this interface is mainly used. These are the main part of that. Then we have the code, start simulation, export, and share. Are you able to see this window, the code window that will generate the code? If you write any programmable circuits, if you write any Arduino, you design any Arduino kind of circuit, it will automatically generate the code for that. This is for the start of simulations. Once we complete our circuit, we do the simulation with the help of this button. Then we have the export. Export, if suppose I want to export my design circuit to generate the PCB, so you can generate this export button and you can generate the file of .brd file. .brd file is input file for PCB designing. You can share this your design circuit with anyone. Suppose I want to share this design with the students of class second year class B ENTC, then I can share with that this window. Now, it's important. This is a circuit area. This area is a circuit area where we'll design our circuit. And to design this circuit, you can see the components. We have a list of components. We have the components, basic components, all components, basic Arduino, microbit, circuit assemblies, and the all. So we start with the basics. So first, by default, it will select as a basic, or you can find a particular component with the search window also. If you need to find specific components, you can find that component using this search button also. So first we'll do the experiment of LED. First we'll do the experiment of LED. So how we'll perform the experiment of LED? We switch on, we turn on and turn off this LED using the switch. And the second experiment will do that for the NAND gates. This will give you the real feel of a breadboard, how to use the breadboard, how to connect the batteries, connections, LED, resistance, and all this. So it's a very good interface to learn that digital lab that is of Tinkercad tools. Now, let's suppose we first select the breadboard, a small breadboards. We require the small breadboard. You click on that small breadboard and put that small breadboard into this active region. So we first select that and we put into this active region. So for designing of LED, I required one breadboard. And along with this breadboard, we can use a 9-volt battery or we can use a small battery also. But we have the option. So first we'll select this small battery of 1.5 volts. So when you click and when you select, when you put this small battery at the active window, this new window will pop up. This will provide you the facility that you can connect the 2 batteries in series, you can connect the 3 batteries in series, you can connect the 4 batteries in series. So you can increase the voltage range if you required. You can select the type of battery, AA, AAA. And generally, we in our house we use this AA, AAA type of batteries. The thick one or is a thicker one. So for this simple experiment, we use a simple single battery and AA battery. And the button switch, if you required, you select this yes. So we'll have a switch button with the battery. Is that clear? So
Yes,
first
sir.
we select this breadboard, then we select this battery. In this battery, we use a one single battery with AA type, and the switch button is required. So we put
Sir,
that switch button is required. Yes. Okay.
uh,
Yes.
so the
Yeah.
components on my screen are very large. I can see
The
everything
components at
properly.
your screen is very large.
Yes, sir.
Large.
The
So you can
components are
zoom in or
very
you
large.
can zoom out. You can zoom out that. So you can click in this zoom to fit.
Okay.
Press F.
Okay.
If you press the F, then all these components are now fit to your screen. Okay. So we have one breadboard, we have one battery. Now we require a LED. So we select the LED. And when you select the LED, it will show the terminals. It's a cathode and it's an anode. And one more window will pop up that will give you the facility. You can use a red color LED or you can use a blue color, orange color, yellow color, green color, or white color LED, whatever you want. So suppose here in this practical, we are using the red color LED. So we'll select the red. Then we require to have a switch. So we select the switch button, and we select the switch button and we press the switch button to here. And apart from that, we required a multimeter. Multimeter is a unit that is used to measure the voltages in current. So this is multimeter is here. So we select the multimeter also. So these are the main components which we require to perform the first experiment. We list that components. We required a breadboard, a small breadboard. We required a switch, LED, battery, and a multimeter. So first we'll see the example of the multimeter, how to use the multimeter. So this is a positive terminal of the multimeter. You click on this positive terminal of the multimeter, the green wire will come up and you terminate that with the positive terminal of this battery. Then you select the negative terminal of this battery. To turn the wire, you just click and you connect the negative terminal of this battery with this multimeter. Now you require to do these two connections. The first connection, you connect the positive terminal of this multimeter to the positive terminal of this battery, and negative terminal of this battery to the negative terminal of this multimeter. Now after that, we start simulation. We do this simulation. So when we do this simulation, we'll find out that key it will show the voltage provided by this battery. So we have selected the one for one battery. So it will give the voltage of 1.5 volts. Now suppose I want to measure the current passes through the battery. So on the multimeter we have the option. You can select the ampere. So it will give you the 3 amperes of current. So this battery is of 1.5 volt with the 3 amperes of current. And if you select the resistance, so it will give the error. There will be no resistance across this battery. So there is an error, and we have the voltage 1.5 volt and 3 amperes of current. Suppose I required more voltages and more current. So suppose I select the two battery and stop simulating and start simulation. So you can see the voltage is now a 3 volts. The voltage is just get double, but the current is the 3 ampere. It remains the same. So you can use a 2 or 3 batteries to increase the voltage for a particular example, particular application. But here I required only the single battery. So I'll do that. So all of you are able to do that, this experiment up to the.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, so you are able to now you press the stop simulation and we'll redesign our circuit. So you select this wire, you delete this wire, you select this wire and delete this wire also. Now we require to make the connection on this breadboard. So now we'll see the property of this breadboard. What this property is that key, you see that okay, if I put any voltage onto the one part of this horizontal line, then all these connections are get short. Short means they have the same potential. So generally, we this line we use to get the power supply. So we connect this with the power supply. So all this dot will have the same potential, means you will get the high voltage, the 5 voltage. Then the second we have the negative. So for the negative, we generally use the black color. So we change the color and we use the black wire. Now, so first we require to do these two connections when we design any circuitry. हम physical में design करते तब भी हम ऐसे ही करते हैं. We'll first do this two connections. The one connection with the breadboard is for the battery, for the positive terminal of the battery, and second connection is for the negative terminal of the battery. Is that clear? So this you can see that if I select any of this connection node, then this show the green color. The green color means they get short. Short means what? They have the same potential. So you choose this connection, either use this connection. They have the same potential of 1.5 volts, and this potential is grounded. So this is a ground terminal. So it's a complete ground for your circuit, and this is supply rail for your circuit. So these are known as a rail to rail connections. This is known as a power supply rail, and this connection is known as a ground rail. So we'll first do these two connections. Now we require to connect the switch. So switch is a 3 terminal. So you see that the first terminal is terminal 1, second is a common, and third is a terminal 2. So in the middle of this, the common terminal, you connect with the supply voltage. So I change the color. I require to have a green color. I choose that green color. When you click onto the common pin, you find out that these buttons, the dots are short circuited, means at any you can select any of this connection node. Suppose I select the second one and I put that connection with the supply voltage. So this middle leg of this switch we connect with the supply voltage. Supply voltage means 5 volts. Now, the next terminal number 2. If you select the terminal number 2, then this the whatever the potential you apply onto this, that is common for the terminal number 2. So now I suppose I want to select this third dot in this terminal 2, then you connect that with the this terminal, the anode of this LED. Then you connect this cathode of this LED to the ground. Now, to connect the ground, to make the ground connection, we require to change the color. So we select the black color and we connect the black color to that. So we make these connections. I think we have a closed loop. We can see that the current starts flowing through that part. It goes to the switch, and when the switch is closed, it goes to this LED. This LED will get on when it get the high voltage, then grounded, and then we have the closed loop path. We know that for the flow of current, there should be a closed loop path. So this switch, if this switch is open, it will create the open loop. And if we press this switch and we get the switch is closed, then it will give it the closed loop path. Now, once we complete these connections, so how many wires we required? 1, 2, 3, 4, and 5 wires we required. Now we do this simulation, and if I close the switch, if I close this switch means the 5 voltage, 1.5 volts, these two terminals get short circuited. It apply the 1.5 voltage to the positive terminal of the battery, LED, and the negative terminal is connected with the ground. Means you apply the high voltages. You put this LED into the forward bias condition, so it will show you the color. It's a turn on when your switch is closed, turn off, turn on, turn off, turn on, turn off. So all of you can see when we turn on the switch, this LED get means on, and when we turn off this switch, the LED is off. On, off, on, off. You can change the color of LED if you require. Suppose I require that this LED should be a blue color LED or it should be white color LED. So you can do that also. When you turn on, turn off, turn on, turn off, you can change the color. Now I require that this should be green color. So turn on, turn off, turn on. All of you now stop the simulation. So all of you completed this experiment.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes.
Have you got
Yes,
that?
sir.
So are you able to see that the LED is turned on when the switch is on and the LED is turned off when the switch is off? So this is our first experiment. Now the next step is to click onto this left hand side window to change with your name. Suppose I save this with the Wabonima LED testing. So you put your name here. So you'll find your name is appear on this left hand side, Wabonima LED testing. So this is my name of my experiment number 1. So you put your name and the experiment name is LED testing. Now we'll see some more examples. So this is clear. Now it will give you the feel that we are working on the hardware because you are making the connection, you're using the breadboard, and you are connecting the LED switches, battery. So this will give you the real feel of doing an experiment using this breadboards and circuits components. Now suppose I forget to make this connection. Suppose I forget to make this connection, and if I try to run this, so the LED is off because LED is not getting a voltages of 1.5 volt at the anode. So how do you measure that, and how you will resolve that kind of problem? So you can resolve with the help of this multimeter. You connect the positive terminal of the multimeter here. We connect the positive terminal of this multimeter is there, and the negative terminal of the multimeter with the second leg of this LED. And we'll try to get this. So the voltage, you see the voltage we'll get across this LED is 0 volts. If you get the 0 volt across this LED means what? The LED is turn off. Forward biasing of this LED, it required to have we apply a 0.7 voltage in forward bias condition. But here, the voltage across the LED. So from this, you can select, you can identify, you can test your circuit with the help of this multimeter. And suppose this connection, you connect it properly and start simulation. LED is on, LED is off. Suppose in case this switch, you connect this connection. Sorry. Suppose you make this connection. Suppose you make this connection and you do the simulation, and the LEDs continuously switch off. LEDs continuously switch off means the potential is across the LEDs again not appropriate voltage is applied, because this switch, this should be connected with this terminal number 2, but we have connected by default, by mistake we have connected with the 11th pin, 11th number of connections. So that you can easily identify with the help of multimeter. If you apply the positive voltage, if I apply the positive voltage here, and if I apply the negative voltage with the ground, and if I measure the voltage across this, measure the voltage across this, so this voltage is 1.5 voltage. This voltage is 1.5 voltage, but this wire is not connected with that potential. So because of that wrong connections, we'll not able to get the output correctly. So for the correct output, we must be aware with this signals and connections. So this is our first experiment, that is LED testing of LED using Tinkercad. Now we'll do the second experiment. Apart from that, you can see that at the right hand side corner, the circuit view, and one more view is there, that is known as a component view. So when you select the component view, so it will give you the list of components which are required to complete this circuitry. So we have used one battery, we have used one green light LED, we have used one switch slide switch, and we have used one multimeter also. So it will give the list of components that are required to design a circuitry, and you can export this. You can export this to the eagle.brd extension, with the file extension is .brd, and that is generally used to design the PCB. So once you tested your circuit, you can design that circuit onto the PCB with the help of this. So is this fine?
Yes, sir.
Yes, sir.
Okay. So
Yes, sir.
move to the next experiment. So we'll perform the next experiment is of NAND gate. So you click onto this Tinkercad, and you can see your circuit is here. You can see this circuit.
On the
Are you able to see this circuit? This circuit is now saved on your profile. So if you require to modify the circuit, if you require to add a more component to the circuit, you can easily do that. Now we'll again create a new circuit. So first we'll click onto this create a new circuit, and now we'll select Again, we required to perform the experiment of NAND gate. We required a breadboard, a battery. We required LED. We require the two switches. The one switch is for the input one because two input NAND gate, and second switch is for input second. And we require the 7400. So if you are not able to get that 7400, you just search that 7400. It will give you the list of the available ICs. You select this IC. You put this IC on this pitch area. This is known as a pitch area. The interface part or the pitch part of this breadboard. So you put this IC onto this pitch area so that you'll get the connections. Now you see that key on this IC we have the notch and we have the dot also. As I told you, this dot and this notch are used to count the pin numbers. So we start with here. This is pin number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. The 14 pins are there. So it's a DIP package, 14 pins are there. Now we'll start to do the connections. So first we select the battery with the switch. So we put this battery with the switch. Then the positive terminal, we first make the one rail of this breadboard with the positive voltage, and the second rail of this breadboard. So we'll use a black color here because of the ground. And this ground so it's again a dual rail. The two rails, first rail we define for the power supply, the second rail we define for the ground signal. Now we required for the switch, this is work as a switch A and this is work as a switch B. To work as a switch A and switch B, we require to connect the middle point of the switch to this power supply for the both switches. Sorry, it's a black color. So it should be a green color. So we select the green color. The middle lag of this switch should be connected with the power supply. So we connect here. Again, this should be connected with the power supply. So this for the two switches, we connect this. Now the first end of this is the input A. So we connect this input A with the node A, the first pin. We connect this second input of the switch. The terminal 2 of the switch is to the pin number 2 of this IC. So we connect with the pin number 2. Pin number 3, we connect with the anode. And the cathode of this LED, we connect with the ground. So now we have the closed loop path. So you see, first we require to connect this power supply, then it's required to connect this ground. Then this middle leg of this switch has to connect with the power supply. For the both switches, the output of the switch is a input A, so we connect the first pin. The output of the switch is input B, so we connect with this in pin number 2. And output of this IC, the NAND gate, the first NAND gate is at pin number 3. So we connect the output with the anode of this LED, and the cathode of this LED we connect with the grounded. So this ground should be in black color. So we'll choose the black color and we connect this cathode to the ground. Now we did. So done. So all of you are able to get these connections?
Yes, sir.
Yes, sir.
Yes, sir.
So have you complete at this stage?
Yes, sir.
Yes,
Okay,
sir.
so
Yes,
shall
sir.
we move to the next stage?
Yes, sir.
Okay, fine. So now in the next stage, All the connections are complete. Now we'll start the simulation. If we do the simulation, then for the 0, 0, this LED should be, output should be 1. For 1, 0, this should be 1. For 1, 1, this should be 0. But for this connection, it is working, and for other connection, for 0, 0, this LED is not working. Because, can you identify the error in the circuit? Anyone can identify the error in the circuit? Where is the mistake in the circuit? Anyone can?
सर स्विच को हमने सर पॉजिटिव टर्मिनल से कनेक्ट नहीं करा.
We have connected this. The middle leg of the switch is connected with the positive terminal.
अच्छा अच्छा ठीक है.
Is this fine? Is the circuit is working fine? Because 0, 0, the LED should glow.
एलईडी नेगेटिव पे लगाई हुई है.
LED negative पे लगाई है, but LED we have connected with the cathode, we have connected with the ground, and anode we have connected with the third number pin. तो ये भी ठीक है. Anyone else can
Sir,
guess?
the IC should also be connected to the power supply, right?
Yes, yes, yes. That's the mistake. We have not connected this power supply and ground pin of this IC.
Yes, sir. Yes, sir.
है ना? This the seventh pin. It is a ground pin. It should be connected with the ground. The seventh pin should be connected with the ground. And which pin we must connect with the power supply?
So 14.
14.
This is the 14 pin. You see that when you click on that, that is power. Power you have to connect with the power supply. So do not forget to connect the IC with the power supply and ground. So the 7 pin is also always connect with the ground, and the 14 pin is always connect with the power supply. I will do the simulation. Now you see. For input 0, 0, the output is 1. Input is 1, 0, the output is 1. Input is 0, 1, output is 1. And for input is 1, 1, the output is 0. This is working perfectly. So do not forget to connect this IC, the pin number 7. You should always connect with the pin number 7 to the ground and pin number 14 to the power supply. And it should be a black color because it's a ground. This connection should be in black color. So this will give you the practical feel to perform the experiment, where to use the breadboard and where to connect the switches, circuits. So this circuit is working perfectly. You can generate the component. We can generate the component list. So we require the two switches, one LED, one battery, and one AND gate. So we can switch to the circuit mode, to the component mode. We can start the simulation. We can export. We can share this. You can zoom in. You can zoom out with the help of F key. You can fit the circuit into the screen. So these are the shortcut commands that can be used during the testing of the circuit.